Let's take a look at this tangent squared of 2 theta is equal to 3 problem in your section 1.4 homework. So what I'm going to do with this one, the trig function is already by itself, but it's inside of a tangent squared. So I'll go ahead and say I need to take the square root of both sides first. I'll go ahead and do that here. Tangent squared of 2 theta is equal to 3. And we want our solutions for theta to be between 0 and pi, so we'll have to keep that in mind. If theta is between 0 and pi, that means 2 theta is greater than or equal to 0 and less than or equal to 2 pi. I put 2 pi there. I meant 2 theta. Sorry, guys. So now whenever we go about solving it, I'll go ahead and take the square root of both sides. I'll get the tangent of 2 theta is equal to, and whenever we take the square root of both sides, the side not containing the variable you're solving for has to be the positive or negative. So I'll get plus or minus the root of 3. So now I need to be thinking about when is the tangent function either equal to the positive or negative square root of 3. And those will be my solutions for 2 theta, and then I'll have to work from that to go backwards to theta. So I'm thinking, well, okay, let's consider a unit circle here. Not the best drawn one. Sorry, guys. Now, whenever the tangent is the root of 3, you might even want to think about that as the positive negative root of 3 over 1. Because I know the tangent is the ratio of sine over cosine, or the vertical component over the horizontal component. This is telling me in quadrant 1 that I need to go up more than I move to the right. There's only one of our common angles in quadrant 1 where that happens. That's at pi over 3. At pi over 3, the vertical component goes up the root of 3 over 2 units, while the horizontal part only moves to the right a half a unit. So that'd be 1/2 square root of 3 over 2. Notice, if I said the tangent of pi over 3, I get, well, that is equal to the sine over the cosine, which would give me the square root of 3 over 1. Now, that same ratio exists at that y value. So I could say, well, that same value over here should occur at 2 pi over 3. At 2 pi over 3, yet again, we're at an angle on the unit circle where the sine is the square root of 3 over 2. At this point, the cosine is a negative 1/2. But now notice that still satisfies our criteria, because the tangent of 2 pi over 3 would be the square root of 3 over 2 divided by negative 1/2. It'd be the negative root of 3, which again satisfies what we need. So you might be thinking, keep in mind pi over 3, 2 pi over 3 has pi over 3 as a reference angle. We need our angular distance to the x-axis to always be pi over 3 radians in order for this problem to have a solution. So our angle down here in quadrant 3 that should work is 4 pi over 3. It's pi over 3 radians beyond pi. And our angle right here should be 5 pi over 3. It's pi over 3 radians short of a full revolution. At 5 pi over 3, we know that the components on the unit circle are 1/2 and the negative square root of 3 over 2. At 4 pi over 3, our components are negative 1/2 and a negative square root of 3 over 2. So the tangent of pi over 3 and the tangent of 4 pi over 3 would both give me this positive square root of 3 over 1. The tangent of 2 pi over 3 and the tangent of 5 pi over 3 would both give me the negative square root of 3 over 1. So all of these angles are solutions. So I would say, well, 2 theta could equal any of these values, pi over 3, 2 pi over 3, 4 pi over 3, and finally 5 pi over 3. And we knew to stop at 5 pi over 3 because if theta had to stop at pi, 2 theta cannot exceed 2 pi, and there wouldn't be any other angles on the first revolution of the unit circle that would satisfy this. So our final answer here, now we just have to solve for theta by dividing each of these by 2, should be pi over 6. 2 pi over 6, which I would rather write as just pi over 3. And then 4 pi over 6, which I would rather write as 2 pi over 3. And then finally 5 pi over 6. That should help us out. The key to this problem is keeping in mind tangent is the ratio of y over x. So that first angle in quadrant 1, I had to go to the value in there that went up square root of 3 over 2 units and only to the right 1/2 of a unit because the ratio had to be greater, the y value, than the x value. That's the only angle in quadrant 1 that case is going to occur. If it were pi over 4, the tangent would be 1. If it were pi over 6, your tangent would be the reciprocal of this. Your numerator would be 1 and your denominator would be the square root of 3. Okay, hope this helps out.